The strength of acids is refers to how readily an acid will lose or donate a proton. Strong acid is an acid that will dissociate completely into ions in water. The 7 common strong acids are hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, chloric acid, perchloric acid, and sulfuric acid. While a weak acid is an acid that will dissociate very slightly into ions in water. Examples of common weak acid are hydrofluoric acid, hydrogen cyanide acid, acetic acid, and a nitrous acid. Strong acid will dissociate completely into hydrogen ion or hydronium ion and another anion. The right-handed arrows indicates that the reaction goes to completion. For weak acid, reversible arrow is used since the weak acid dissociates very slightly into hydrogen ion or hydronium ion and another anion. Strong base is a base that will dissociate completely into ions in water. Examples of strong base are metal oxide and metal hydroxide that comes from a group 1 metals and also group 2 metals except for magnesium. A weak base is a base that will dissociate very slightly into ions in water. Examples of a weak base are ammonia, any amines, and also hydrazine. Same as strong acid. To write down the dissociation equation of a strong base, we are going to use a right-handed arrow, while for a weak base, reversible arrow is used to write down the dissociation of a weak base in water. pH is a measure of concentration of hydrogen ion or hydronium ion in a solution. So, to find the pH, we need the concentration of the hydrogen ion or the hydronium ion, since pH is equals to negative log concentration of the ions, while pOH is a measure of the concentration of the hydroxide ions in a solution. To calculate the pOH, we need the concentration of the hydroxide ion, since pOH is equals to negative log concentration of OH minus. Neutral solution has a pH equals to 7. At this condition, the concentration of hydrogen ion equals to the concentration of the hydroxide ion. A solution with a pH less than 7 is called as an acidic solution. At this point, the concentration of hydrogen ion is bigger than the concentration of the hydroxide ion. If the pH is bigger than 7, the solution is said to be a basic solution. At this point, the concentration of the hydrogen ion is smaller than concentration of the hydroxide ion. Since Kw is equals to concentration of hydrogen ion times with concentration of hydroxide ion equals to 1.0 times 10 to the power of minus 14, if we put negative logarithm on both sides, we will get negative log Kw equals to negative log concentration hydrogen ion plus negative log concentration hydroxide ion equals to negative log 1.0 times 10 to the power of minus 14. So, the negative log Kw is a pKw. Negative log concentration hydrogen ion is pH, plus with negative log concentration hydroxide ion is the pOH equals to 14. So at 25 degrees Celsius, the summation of the pH and pOH is always 14.